More fun with probability. Let's take a look at figuring out whether you were accurate and precise with your individually or independent work from the last time. So Charles had a spinner, and we were supposed to write an expression for the problem Charles needs to solve. Is there more than one way to do this? Well, I say yes. One of the ways that we can attack this is by considering the whole spinner. And if we do that, we could, and I'm going to put this up on top because we're going to need some room for Mrs. Mennes-Coon to show you. And if I'm going to talk about the whole spinner, I'm going to start with the whole thing. And then I would subtract the parts that I already know, which is subtract 1/3, subtract 1/8, subtract 1/4, subtract 1 more fourth, and that looks very confusing. I really need to take a moment and think about what I could have for my fraction common denominator, because when I'm doing subtraction of fractions, that makes it a lot easier for me. To begin with, I am going to think about a number that they all have in common, which is going to be 24. In order to subtract the fractions from this whole, I'm going to change the whole into a fraction that has 24 for the numerator and denominator. And then I'm going to rewrite each fraction. 1/3, if I multiply that by 8/8, becomes 8/24. 1/8, if I multiply that fraction by 3/3, it would become 3/24. The next one, 1/4, if I multiply that by 6/6, it becomes 6/24, which I would get to do again. And there we go. And most of us remember that we do nothing to the denominator. Once they're all common, I just subtract or add what's on top in my numerator position. So 24 subtract 8 gives me 16. 16 subtract 3 gives me 13. 13 subtract 6 gives me 7. 7 subtract 6 gives me 1. Let's see if I get it using my other strategy. Instead of using the whole spinner, I could just focus on the half, which is including that mystery piece. And if I do that, I would have something similar, which would be 1/2. This time, I'm going to only have to subtract two fractions that I already know. 1/3, and I'm going to combine these in a set of parentheses. There's another way you could do that, which does not include parentheses, but this is going to be a little bit different twist on what's above. And to change this, again, I'm going to use my 24 as my denominator. 1/2, if I convert that to an equivalent fraction that has 24 in the denominator, that would be multiplied by 12/12, which would be 12/24. Subtract the quantity of 1/3. If I look back up here, my fraction up there was 8/24. And if I go up here, my fraction equivalent for 1/8 was 3/24. So I can simplify this using order of operations. I would have 12/24, subtract 8 plus 3 is 11, and I still get 1/24 for my label for my missing spinner piece. And let's move on to Jonathan has measured some flour, but sometimes when we're cooking or baking, we spill things. So he has spilled part of it. In order for me to do this, I'm going to start by writing down, well, actually, I start by looking at the number facts that I have up in my problem that I need. I'm going to start with 2 cups of flour, and I only have 3/8 left. I'm going to subtract them because I'm comparing to find out how much he spilled. To solve this problem, my 8 is my denominator, so I'm going to change this whole number into a fraction that would be equivalent to 2, but has an 8 in the denominator. And that is 16 eighths. When I subtract 3 eighths from that, I get 13 eighths. And I know that that's not a very easy way for me to think about measuring when I'm baking. So I'm going to change that into a mixed number by looking for how many whole groups of 8 I can take out of 13, which would be 1. And I have 5/8 of a cup left over after my conversion. So this is how much he spilled. That was a lot of flour. And now we're moving on to Maggie and her book club. Maggie is making muffins, and as I read this the first time, since we're going over this, I'm going to focus in on what I need to pull out of that problem. 18 muffins, 12 people in the book club, and we're dividing them evenly. And in order to do this, I think about the 18 muffins, and I'm going to divide them to 12 people, which is going to get me, well, there's a couple ways I can do this. One thing I could do is I could reduce this to make my numbers a little bit easier to work with. And then I keep moving along here, and I have everybody gets one whole muffin. And actually, when I get done with all of my math, each person gets 1.5 muffins. And another way to think about that is each gets a whole muffin. So that would be 18 subtract 12. 6 muffins left, divided evenly, is 1/2 per person. And then the last problem that we have to look at, a simple multiple choice problem. If the probability of getting a result is 75.3 or 75 and 0.3%, the probability of not getting that result, I would subtract. So when I'm looking at that, I'm going to subtract what I know from what the whole is, the whole thing. And that would match up with letter C. And so I would show that my chance to get the result equals 75 and 0.3%. The whole equals 100%. And if I subtract, then I end up getting my answer, which is borrowing. And I end up with 24 and 0.7% of not getting the result. Let me slide that up so you can see what I'm writing, not getting the result.